Hey everyone, it's Norm from Tested here, and to wrap up this week, I have another laser cutter project, although this one is actually more of a lighting project. So one of the things I've been kind of obsessed with are these LED signs that you see on Etsy. The idea that you can take the LED strips that are just commonly available today and make them into something that looks like a neon sign. I've seen people offer these as custom designs. I've seen some prefab ones, and I wanted to see if I could make my own version of it based on what I could figure out from the bill of materials and having a laser cutter here. And timing was perfect because this week's actually me and my wife's anniversary. So I decided to use this as a project to make an anniversary gift for her and to do an LED quote unquote neon sign. So it looks like it's a neon tube, but it's actually just an LED strip and using her own handwriting, writing out her name. So I'm going to walk you through the process that I went through to make this sign. I'm going to try to make another one today as well, based on the lessons that I learned going through that process, and hopefully it'll help you in making your own signs. But the first off, it was finding out what these LED strips were. Now in the past, I've talked about some very common off-the-shelf LED strips that you can buy to light your shelves, your bookcases, to use in your own projects. There are some with addressable RGB full color, some that are just a fixed color, maybe a warm white or a cold white. And what I wanted to find was what were the ones that looked like this neon light. Were these maybe the COB chip on board LED strips that I talked about recently? And it turns out it's actually far simpler than that. What you have are these now commonly available silicone tubes that have an LED strip that don't point upward toward the tinted tube here, but actually point sideways and then bounce the light up into this tinted silicone tubing. And that allows you to actually bend it in all sorts of angles. Normally, if you have an LED strip, because of the electronics and the tape on it, it's tough to kind of get it to wrap around a curve if you're laying it flat. But if you have the LED strip on its side, it actually can coil up quite easily. And so manufacturers have created this tubing that comes in a bunch of different colors, and it's not even the color of the LEDs themselves, it's actually just the tinting of this top diffuse layer. And then the strip inside is actually just like really common, 2835, just standard cheap LED strip, but then embedded into this silicone tubing. And we can actually cut a piece of this off to take a look at what it looks like. If you look at the side here, you can actually see some markings, and that tells you that you can actually cut these LED strips to size. This one that I found, I'll have links in the description, are about $22, $23 for about 16 feet, so a little more than $1 a foot. And it's better to buy, two of them just in case. But I can show you if I cut right here, a piece of this off, you can see that I've actually exposed it. It is just an LED strip put sideways right here. You can actually see the individual chips, and where they have the indications, the mark of where you can cut them are where the copper pads are for both 12 volt and also the ground. It's how you're actually going to be able to wire this stuff. So that was like the most important part, figuring out what these pieces were. Again, not too expensive, and you can get them in a variety of different colors. And so I got a few different colors to experiment with. And the next step was to figure out how to mount this onto a design. And if you look online, there are a bunch of different ways to mount this. You can mount them in some milled wood or MDF. A very common option is to get a wire grid that you can like zip tie or wire tie around and bend these and contour them to different shapes. But what I want to do, because I had access to a laser cutter, is use an acrylic backing to cut a very precise channel. And that channel is where I would then press fit this 6mm width of this tubing into. Now, you can do this with any vector design, and I'll show you the process. If you go into your vector program of choice, you can just find a piece of vector that you design or something you downloaded from the internet and create a channel. But what I want to do for this particular project was to turn something that was handwritten into a large-scale sign. And so I opened Adobe Fresco on the iPad, and I had my wife write her name a few times on the iPad, which then created a vector of her handwritten name. Now, because this project's already completed and I didn't get a chance to screen record that process, I can do it one more time for you. And I'll open actually Adobe Illustrator on the iPad here, write my own name out, and then let's head over to the computer and I'll show you how to turn that and process that vector into the channels that fit these LED tubes. Okay, so I've imported my scribble here into Adobe Illustrator, and as you can see, first thing I'm going to do is just clean up the handwriting just a little bit, because I don't necessarily need some of this overlapping bits of the writing here. I want them to be pretty clean. And I'm also thinking about where I want the letters to be one continuous line versus separate lines, because every time it's a separate line, it means I have to cut a separate LED, part of the LED strip, and then wire it. And it's just a little more elegant if it's one line. Although overlapping parts of the script won't necessarily work. You'll have to actually cut the cord and then reconnect it to do any overlaps. So I've scaled it here. I've decided to place my name in a circle. And the important thing here is using the offset path tool in Adobe Illustrator. That creates an outline of your existing vector with a radius that you choose. And because I know this tubing is 6mm wide, all I have to do is create an offset of 3mm on each side, so 3mm on an outer edge and a 3mm on an inner edge, which will then give me a 6mm channel. So I do that, and then I delete the original vector, and what I'm left with is an outline. And I'm double checking, I'm using the ruler tool here just to check the widths of this new channel that I've created to make sure it's about a little under 1/4 inch, which is 6mm. And the important parts are where there's going to be some curves. Now, this tubing, while it can do curves, it doesn't do a sharp edge, like a sharp right angle, or you see like where the letter R or the letter M is. There's some pretty sharp turns here. It's not going to do those that well. You're still going to have a little bit of a curve. So I want to make sure, again, that I have enough space, and also doing a little bit of cleanup as well for any of the imperfections. Next up, I'm going to be using the Pathfinder tool to combine some of these channels. Like, for example, I want the R and the M here to be one continuous piece of that LED tubing. And so I can connect them at the bottom, maybe stretch out a little bit of the anchor points, again, to create enough space for that turn. And then using the Pathfinder menu, I can create one shape out of these two shapes. I've also decided to add a background element, and here this is just using the pen tool to draw out a generic lightning bolt. Again, you could import any vector, and I'm using, again, the path offset tool to create a 6mm wide channel for that. This is one of those projects where the Pathfinder tool is super helpful. Lets me combine shapes, create intersections, and create negative space. It's a look up tutorials on YouTube or on the internet for how to best use the Pathfinder tool, but I use a lot of trial and error and always making sure to back up my shapes before I do any manipulation, so I can always revert back to a previous state if I'm unhappy with the result of combining or removing a shape. So the idea here with this design and the design I did for Danica's sign is I'm going to use acrylic sheet to create the channel, but I also want a second acrylic sheet behind it to create a backing that the LED tubes can sit in. And for that, I'm just going to use a clear sheet of acrylic, and because I'm going to have the extra layer, I can use it to create maybe a little bit of a drop shadow, an offset. So because my shape here, the outline is going to be a circle, then I can create a second circle, which is going to be the backing sheet, and then just move it slightly offset, off center. And here, the important thing is not carving out the same channel for the tubes. I don't want that because I want the backing, but here it's important to create some holes that the wires, the ends of the tubes, can then connect and pass through. And so I'm looking at the shape, I'm looking at the channels I've created here, looking at where the terminal, the end points of each of the tubes are, and then drawing just here, just a circle, can be any shape, but creating a hole, punching a hole through the backing sheet so that I know the wires are going to drop through the backing sheet and I can then wire them up in the back of the whole display. One thing I learned through the process of going through this the first time is aligning my front and back acrylic sheets became a little tricky. So this time around, I remember to actually etch in the channel on the backing sheet. Not cut through, but just create an etch that I can use just to register the top and bottom sheets. I know how to perfectly align them so that the holes I've created for the wires, the terminal ends, are in the right place. And now it's time to take this to the laser cutter and cut out our 2 acrylic sheets. All right, so I did capture footage of the next part of this process with that first sign I made. And I took it to the workbench and peeled off the covering of the acrylic sheets. And you can see the first step is to glue and align them together. And it's using some CA glue, being very careful to register the top and bottom sheets. But what I'm then left with is a solid backing of this sign with that 6mm channel. Now I'm going to grab the LED tubing and start laying out the actual the lighting sign. So starting from the left, beginning, just kind of curving the LED tubing around, bending it as best I can. It's pretty malleable. It's pretty well press fit into the channel, and then figuring out where I have to cut them, hopefully matching the end of each of these sections with where the cut lines are on that LED strip, clipping them, and then creating here about 8 different segments of LED tubing. An important thing here is to label them, so you can get a pen or pencil, and on the bottom of each of these, just make a little number so I know from left to right I'm starting with strip 1 all the way to strip 8. All right, so here's where I also had some important lessons learned going through the process of this the first time. As I was laying out this LED tubing in the channel, I was trying to conserve as much of the tubing as possible. I didn't want to waste any of this material. So I would lay this out in the channel, find the end of the letter I was getting to, and then snip it, and then just continue using it on. And what I realized is that that may not have been the best idea. I should have given myself a little bit more slack, not in terms of the length of the tubing itself, but onto the slack onto the actual copper pads that I would then be soldering the wires to next. If you look at the soldering footage, the pads, when cut in half, there's not a lot there to work with. And actually, because the silicone is, for this model, is pretty tightly packed, getting those contacts, getting the wires soldered onto the pads was a little bit of a hassle. And so to do this again, what I would do is lay this out in the channel and then snip maybe 1/8 of an inch past the line so that I'm giving myself all of the copper padding on one end of the strip, and then discarding that length of the LED strip. The rest of that length, that's only about 1.5 inches I'm not really using, and then continuing on with the next segment in the drawing. And with each segment, you're basically wasting one section, but that's okay. You're gonna get it back, make up for it in terms of your time because you'll have that much better of a time soldering the wires to the connectors when you have more of that copper padding exposed. And with the soldering, the process is pretty straightforward. You just make sure you have your soldering iron, solder some wire. I'm using 22 gauge wire here. If you look at how the LED strip is oriented on the side, the positive side, the 12-volt side, is closest to the tinted silicone on the quote-unquote top of the tube. And the ground is gonna be closest to the bottom where you're adhering it to the sign itself. So it's just a bunch of soldering. For my first pass, I soldered both sides, made sure I had enough wire left. They also sell, links in the description, these end caps that already have 2 pre-cut holes that allow you to nicely cap the ends of these cut pieces. It actually helps create a better fake neon look. I also tried using some heat shrink tubing just to help isolate the wires, but it ended up being a little bit too cumbersome. It didn't really fit well with the end caps, and because I didn't give myself enough of some of that copper padding, the solder points were a little bit delicate, and so I didn't want to stress them by trying to yank the heat shrink tubing over it and then trying to cram it through that end cap. Another important thing to do while soldering, because of how delicate all the connections can be, is to make sure you're testing your connections after you solder every pair of wires. And so I had some alligator clips connected to a 12-volt power source, and just every time I would put an end cap on or even solder 2 connections, I would test it to make sure the strip was still, that segment was still gonna light up and that there wasn't any shorting with that, or I'd have to go resolder the connection. So always be testing as you go along. So finally, I have all my pieces laid out, and very thankful I made a mark and numbered each one because some of these look very similar. And so the next step and close to finish is actually to get them aligned inside the channels. And I can just press fit most of this and poke the wires through that second backing layer, through that hole that we carved out. And here, it's where I realized that I didn't actually need to solder both sides of these LED strips. I was thinking about wiring this whole arrangement in serial, where power would come in one end and then pass through each segment to the next segment. But then I realized as I was doing the wiring that I could also have this powered in parallel, where I would have multiple ground or multiple of the power leads tied together, and all you would need is to make sure one end of each of the segment had power and ground connected to it. And that ended me saving me a lot of time. And at the end, it's a little bit messy, my wiring in the back here, but again, always testing the connections, making sure all the pieces are lit up. And after doing a little bit of cleanup, we have a finished sign. Whew. All right, so that's how I put together not one, but two of these faux neon LED signs. Just finished this one today, and let's take a look. Yeah, not bad. Turned out pretty well. My penmanship's not as good as my wife's, but I think she enjoyed that present, and I certainly enjoyed going through the learning process of putting one of these together. Hopefully you found it interesting as well. Again, I'll have links to all of these parts in the description below, and if you end up building one of these or you have other LED or laser cutting projects in mind, let me know in the comments below. But until next time, have a great weekend, and I'll see you later.